Now we will start to explain this place. Each of the color can be represented with numbers, we said it. Now we will speak about RGB color. Now we said we have each pixel, so each pixel is there. In each pixels we have RGB colors. How we can show that? Now I will show you. Just think, in this place, maybe I can draw it. Maybe here. It can be like 5, I think. Will be good number for write things. We can say yeah, it can be something 300, 253, all right, 253 and 78 and 14. So now we will say red, our red will represent here 20, 253. Our green will represent here 78. And our last blue can represent here 14. So what I'm saying here, we have RGB colors, okay? RGB colors 0 to 250. We have each pixels have limit 250, 255. Okay. Now what I want to do here, I will tag it in this pixel to show it you. I think this one will be good here. It's really difficult, right? It can be there, okay? You can see from here. And for here, I will write here RGB color. And for RGB color, I can do it. Maybe it can be like maybe 10. For put it here for embedding it. Embedding. I'm sorry. Now also I will come here and I will say arrow, and for arrow I want to put things here a little bit like that. Where is it? Arrow here, and you can say this way. This is the pixel, right? Pixels. So RGB colors, I mean. This is the pixels. And also what I want to do here, I want to put there also something in this place. Maybe I can put something like that. And in this place, maybe I can put background white, like F. Where is it now? Oh, just delete it. Come here and say F, 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 something like that. And in this, what I want to put there, I want to put some ellipse. I mean, yeah, ellipse like what? Like that. Yes, ellipse, and in ellipse, anyway, maybe it can be some different color like that. Mm-hmm. Then in ellipse, I want to put some color. I want to draw it. Something like that. Just you can think in this place, in this circle, ellipse, we have there just what, like 253 and 78 and 14, something like that. Okay, you can think something like that. We have this in this place, in this pixel. Okay, you can think like that. So what I'm saying here, I think you got it. RGB color, three colors coming next to next, and it's just gives us RGB colors. It's each pixels of them representing color, okay, representing pixels. Now we will write something here we can do together. Yes, I think, no, maybe this place will be amazing. Now I will say, when you consider that a typical image, a typical image image has millions of these pixels, and uh, and and a typical video shows shows 30 images. This is really amazing place. Just try to understand here. In one movie or series, videos, there is 30 images in per seconds shows. So per second. Now we are we are taking we were taking about about a of lot of data here. Yes, really. So now I will show you some other kind of things. Now what I want to do, yeah, maybe I can do something like what, maybe upside. 1 minute. Yes, here we have this one. It will be amazing. Take this one and come down. I just think we have this. Maybe we can small it, right? Like that. And I will write something here. And also we can, oh no. Also we can tag this from this place. Take this to right side. Here, like that. And I want to go up. Yes, this place is better. And just what I want to do, I will duplicate this, because our example here, if we have too much pixels, and so it's meaning there is 3 billion pixels in per minute. So I mean per minute. So just think, each minute there is 30 image, okay? 30 image have billion of billion pixels. There's some kind of data, right? Lots of color there, and read it. There is too much information about this, and also duplicate them. Really, what happened? Oh, this is crazy. Let's take them down and come on. Okay, I think you got what I said. It's about images, about videos. Now we will speak also about sounds. There is also some kind of logic like that. Okay, also I want to duplicate this one here. Yes. And this one here, like this. Okay, I think this, you understand what I'm doing here. I will say plus 3 billion, plus 3 billion, but why this is too much small? Yeah, maybe I have to, yeah, if I do something like that, then it will be amazing really to explain the things. Millions, we can say for here, millions of pixels, pixels for pixels per image, pixels per image. And also I want to duplicate it again, and I want to put here, and just I can say for here 3 billion pixels per minute. I think you got what I said. This is really important. Now we'll come here and we will say here sound in binary. Now we saw there, so already we know images, videos. Now we will look for sound. Right, now we will make it again blue. Yes. Now we will write something again here. Each sound is basically a series of vibrations. This is really amazing information. Vibrations. It's just vibrations, not more than it. So in image, we have what we have. We have RGB colors, right? In sounds, so we have vibrations, and computer can represent again with bits, with numbers. The computer can understand. So just our all sounds like A, like B, in our sounds vibrations gives there some value, some volume, right? Some volume can represent there some bits. So if you say hey like that, then hey, it's coming up. And what important there, our all rhythmic tunes, rhythmic words, it will represent with one numbers. For that also we have one word. In 8 bits, there is quality not will be big, not will be more. Quality will be bad. But in 32-bit, it will be amazing because your sounds range of your sounds will be too much different way. I told you so. We are just doing one time two two, so one time one, two time one, and four time one, eight time one. It's just think you will go like 32, 32 time you doing that. Okay, it will be amazing quality there. Anyway, you will see now with me in the, now we will say in the ear, vibrations in the ear. That's good information. And also I want to plot here something like that. It can be like that. And what I want to do, I want to plot their line. Maybe not line, maybe I want to do something like that with green here. And maybe yes, something like that. Something like that. But I think it will not be good. And why am in my hand like that? Mm, yeah, I think I did it. Anyway, I need to stop. Now I will come here and I will say for here sound be here, and down that a series of vibrations. I will write series of vibrations. Where is that? Yes, series of vibrations. Yeah, just put here and do this one. This can be green again. I like because there is no reason. Yep, it's just green. Okay, now I'm coming down again. It's okay. New page. Now, just come on. We can write something here, a little more to explain it. Now we can say vibration. Vibration. Vibration can be represented. Can be represented graphically, graphically as on wave form. This is very good information. So now what we will do? So we can say any point, any point. Anyway, maybe we can write down any point, any point on this wave form can be represented by a number. Look, this is amazing information. Now you are in deep of this computer science. So in system, how to working all real world applications or other things, videos, images and sounds. You speaking translator for translate things in Google Translate, right? You're saying, hey, hello, and it's just translating your sounds to German language, to French, to some other language, Chinese language, Japanese. So it's all about that. The numbers, there is some number communication have. Numbers just going bits, and so I mean bytes and bits just speaking there, okay? There is some speaking between computers, between informations, okay, with numbers. By a number, and this, and this, and this way, and this way, any, in this way, any sound can be broken down broken down into a series of numbers. Now what I said here, broken down. Now you will understand what I'm saying. Coming down. Yep. Now I will plot very difficult things. Help me. Now first I will do this. It can be good. Okay. Then maybe I can do this one black. It's good. And then we have numbers. And I can do numbers here. 50. But it can be like what, maybe we can do here. It will be good. Yes. 50. And like that. And like that. And like that. And also like that. Then like that. That. And like that. Now what I want to do, I will small these numbers, like maybe I can do 8. And yes, I will put some, some assignment, range, yes. But what is the logic here? I think, yes, can be here. And okay, now what I want to do, I will come here. You know what I did here? I think this here and this here and this here, this one here, and just really just we can put here this one. Maybe one time more. If I will matplotlib or pandas library, really I can be fast. I think you don't know for now. Maybe this library, this is a helper library for machine learning, deep learning models. We can visualize things there. I think you got it what I do. Also, we have numbers here. Again, like that. And maybe something like that. Then this one, and this one, and what is it? This is crazy. Oh, it can be like that. And this one maybe here, and I think something can be next, maybe this one. Really, this is very difficult, but I will show it you later. And this one, and anyway, something like that. Okay, maybe this. Okay, come here, just stay here. Okay, now we have some red line here. Yep, starting from here to this place. Okay, line can be white, no, red. and we can here. So I think this one is a little wrong. Maybe I don't know. I'm really not good on it. Sorry, guys. So I just really know. This one can be here. Maybe little more. Yes, it can be here. Or maybe this place. Yeah, something like that. Just I will change the volume. You can think like that. I will put it here. No, maybe here. And this can be here, maybe. Yep. And it can be a little down like that. So it is taking lots of time, but sorry, friends. So it's really difficult because just doing with your hand, and there is no programming, no library. Just you're doing with your hand. I told you. So something like that. Maybe again this one and this one little more maybe. Maybe we can do this one also like that, and this one maybe here. Yeah, maybe this one here, and maybe more two one. This one, it's also here. Okay. Well, I think we have diagram for showed it waveform. Now I will use also again this to do this thing from here. This will be orange. Right, maybe here, right. Orange can be orange. This one here. Think it's looking good. Yeah, I think this one is good. Not good too much, but it's just okay. Anyway, then I need one more for okay for here, for here. Yes, I think for here, and also we need for again for here. Really, this is very difficult. My brain stopped. Anyway, we will do. There is no solution for solve it. And also it will come here and it can be here with this. Can be at this place, I think. Oh, thank you so much. Just it's wrong. Just do it. Then no, not thank you for your help. What I can do here, something like that. So and more, it will go again. It will come here, and you can see it will come down again here. So I think you know what I'm doing here. We have some numbers, and these orange lines following this waves volumes of waves, volumes of your sounds, and it just gives you some values, some a number of your source volumes of sounds, and they are just converting to binary numbers, bits. Anyway, so I think if I do things like that, maybe, please. Yep, really, it is nice. Oh, come here. Yep, do it here. I think, no, this one can be here. And I saw this one is not good in this place. This one, I think. Yep, maybe, no, better. No, it's not good than before. Yep. No. Wow. My brain stopped. Yes. Okay. So what are we do here? What are we doing here? I told you. Now I will do here also. Yep. Yep. It's also good here. I will just add this place. Okay, we have some volume of sounds. I will add there some numbers. Like what? Like this. Yep. We can say 52 for here. To the color for text, our color can be white or blue. Yep. It's why I want to do blue. Blue color. Yep, it's good now. Okay, now for here we want 52. For here it will be 52. And for here it can be like, but this is not mindly. You look, it's like that. But before do it, I will show you some point. Now you will understand better what I'm doing. It can be here because 198 more than this one. It can be there. I was really bored to do it, but you know, for do things I need, it can come down. So anyway, my friend, you know this point. Yes, now really I will stop for give this example again and again because really this hard. So in this point, just yep. Where is it? Yes, this can be here. And for other place, just say for here it's 181, and for other, for this point we have 109. Where is it? Yes, for here we have 78. It will be little, oh no, it will be for here. I mean, yeah. So, and it's just coming down. And I told you there is lots of things turning here. I can do more, but it will take lots of time really to do these things. Anyway, it's what is this? Hmm. Hmm. Wow, it can be here, right? Yes, just please come here and yes, do here. And this one just come here, and these numbers can be next to next. No, it can be here. This one, and this one can be here. So I know what I want to tell you. So you know what I'm saying here. Just don't worry. And all the way, this things will go someplace. This is 178 or 181 or 198. This is just some bits there. Okay, it's representing your sound volume or your sound rhythm, and it's just vibrations, and computer can read these numbers to explain situation about your sounds. Yeah, really, it is like that. And also I will add here two more things. The rectangle again, and I can say just I didn't do these things matching, but you can match it. Okay, you can match it. It is not too much difficult. And I want to put there something with no, yep, now with orange. Where is the orange? Yes, yes. Now this will be big one, and this will be normal. This will be normal. Yeah, this one will be more, this one will be normal. This one will be more, this one will be normal. Why I am doing that? Because this meaning, like some sounds coming more, some sound is little, and it can change. It's all about that. Now anyway, I will come here and it's all the time the sounds, the things going like that. Yeah, maybe here. And I can explain the situation. And no, really, it's not important. Yes, just to tag it again, again. Okay, this is some information like that. Okay, it's thank you. Why this is just stop it. Okay, come down and finish it. Yes, stop. Okay, there is something like that. Okay, don't worry about it. And sound can be broken. Now I will write again here. Sound can be can can be broken down into down into a series of numbers. Okay, so it is also here, and change the color like every number, so color can be like that. Okay, anyway, now we will use again same example, but here what I want to do, I will write something. If you want higher higher quality 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 sound, you will pick 32 32-bit. I told you range of bits, it can change situation about quality of sounds, and audio over 8-bit. Why? Because in 8-bit range of 8-bit, it just can give you some quality. Like, just think you have good sounds, but there is no have numbers can represent your sounds in your sounds depths of your sounds. Anyway, it's 8-bit audio. Okay, it's okay, and just put it here. It can stay here. I think what have upside, yes, this place. Yeah, maybe I can make a little bit bigger this because of our situation change. 30. Yes. Oh, what happened? Yeah, no problem, just we can put here. Come down, and now what I want to do, again I will do something, but now it will be little short than other one. Anyway, I will do very fast. Okay, no, maybe, no, maybe yes, something like that. And we have here 32-bit, and we have 8-bit 8-bit, so 8, no, 9-bit, it's just, wow, 8-bit, also 32-bit. Put it here, and it can stay here. It's good. No, I will do with line. Yes. No, but before line, maybe I can do something with drawing. Now just think, we have here this one. Oh, how I can do that? Yeah. Yes. This one. Yep. All the way it's going like that. And it's coming down right now. Yep. Yeah, something like that. And the other one will be little different. Like what? Like this. It will be like this. this, this, this. So the different things between these two model, the first one, it's just you can see the traffic is too much. So each traffic can represent, so each orange piece, so each orange points can represent with one numbers. In 8-bit, we don't have this situation because we don't have 32-bit. We have just 8-bit in 8-bit diagram. So in you can see we just have their 8-bit, okay? So there is 16 possibility, okay? If you look there, like you will see, okay, that in 32-bit there is, you will see 64 possibility, okay? So anyway, so just think here we have too much this next to next. Anyway, with blue maybe I can do something. Maybe this will be like that, so it will be like that. So anyway, I think you got it what I did, something like that, okay? This is very bad, I think it's not good. It will be like this, 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 then this one, like that, and some point here, like that. And anyway, something like that. But in this one, it's all the time going like that, okay? All the time. It's there is each point, it's just here, each point, yeah, we can go like that. Each point, the numbers, I mean the bits, okay? We have lots of bits there, and our sound quality can be higher than 8-bit. So I think you heard too much outside people speaking, hey, just 8-bit not good. Also for computer same, just 32-bit can represent or can store bunch of number, a bunch of information, but for 64-bit can store lots of things, lots of information. Anyway, it's okay. Now we will write little bit. So what we want to do here now, I will come middle up. Yes. Oh, this. Yep. Now I will come middle here. Yes, more. Yep. Now we will write little bit, man. So more bits. What I'm doing now. More bits means a higher range of numbers. So if you want to understand how computers works on the inside, it all comes down the simple ones, simple ones and zeros. So ones and zeros. Ones and zeros, right? And electrical signals. Signals in the circuits. And circuits behind them. So, behind them. So they they are the backbone of how all computers input, input, store, store, process, and process and output information. It's good information, I think, for you. You can read all this information, healthy information for your way. It will benefit you. Really, it will give you benefit. And also, I just want to add here again one rectangle place. It's for explaining the situation about that. Maybe where is it? Line. It will be 4 place here. Yes, something like that. And also we have here one line again. It will be like that. Maybe a little bit we can take down. Yes, something like that. And we can say here input can be output. Yes, displays input and output, and we can duplicate them. Yeah, just for put down, come down, and this place can be store. It can be no store and process. Can be like that. Yep. Input, output, store, process. So I think you got what I said. More bits means a higher range of numbers. So if there is too much bits, just you can think like there is a higher range of numbers, then there is lots of details a computer can check, sorry. So anyway, now we will look bits, okay, and we will look bytes. We have little bit things now. Okay, now we can say with red, it will be here. Bits, binary digits. Close it and come down. No, where is it? Where is it? Yes, here. It can be red. Okay, and our line, where is our line? Okay, line is already here. And just do it. I think this one. Yep, now if you look the first topic, maybe we can see here binary and data. Maybe, yeah, I will tag this one because we didn't put there anything for that. Anything there about it. Okay, we can go on. Now we will write a little bit. Don't worry about that, just it will take some time. Okay, we can start. Computers. My coffee finished. I don't remember really when I finished my coffee. All the time when I was so when I get my coffee on table, so when I put on this table, I'm just drinking sometime, and when I forget it, and just it is very fun. It's joke, little bit like that. I'm tagging, so I'm drinking a little bit. I'm saying, what the fuck is it? It is like it's too much cold, you know. It's iced coffee and hot coffee together. I'm drinking. So computers store information using bits. Now we know that, right? And lots. Now we will go it. No, not a lot. A bit short for binary binary digits. So bits meaning binary digits is some shorter case for that. So shorter binary digits like stores either stores either the value 0 or 1. Now what I want to do here also, I can do something like that. What fits in a bit? Yeah, we think about that. That's in a bit. I can say something like that, and maybe we can use some little bit different color. Yeah, for yes. Anyway, just tag it here. I don't want to do again and again same thing. Yeah, I can tag it also, and we can say a single. No, where is it? A single bit can only represent two different values. That's 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 not that's not like that. That's not very much. It's not very much. But that's still enough to represent only two two values values state valute state. Now we can tag it, and maybe we can come down. Yep, I will put here. Let's come here. Anyway, this is a light bulb. Light bulb on or off, or on or off. So here notation. I'll show you with that. Where is it? Okay, something like that. We have, okay, and we have line. This is the line. Then just think maybe I can draw it. I'm not sure. Just think, where is it? Think this is this is the, wow, this is very difficult. Our hair is too much small. It's like that, and this one, and this is just lamp, okay? Oh, okay, this is some lamp, okay? I'm really very angry, why? Yes. Okay, anyway, this is something like that, okay? And the first one is nothing, the second one it's light bulb, okay? Like we have, and we can say for this notation, this one is 0, the second one is 1. So the meaning of this, and we can put also here something like state and bit. Oh, yeah, come here. State of that. Oh no. Maybe I can do a little long. Yes, now we can go something like that, okay? Now also we will say here, maybe here. Yes, it's a button, enable it or disable it. Maybe also one example like that. It's just some cognitive information for make your brain little strong to understand this concept. Also, what I want to do, I will tag this one, I think, because I don't want to do again same thing. I can tag it, and I can say for here state bit again, and for here I want to delete this one. Just stop. Wow. Yeah, in this place can be like submit. This one can be submit again. But what is the important in this place? Maybe it can be red. It can be green. Okay. Something like that. And well, again, again. There we have one here I will put, but before put I will write again something like that, and I will put here what is saying here is the current time, M or PM, EM or PM. Good. And we can say for here it can be 9 5 p.m. Can be 9:35 p.m. But PM can be small and PM also can be small. And again, same situation. Okay, so it's okay. Now, so yes. Okay. Now, what I can do, I'm just thinking about that. Maybe I can give you some. We can do some exam practice. Then we can do exam, I think. Anyway, now I will say here, maybe not here, here. I will say consider these settings, screen for uh, for a application users. Now, okay, will be something I will now show it to you. Yes, here we have, anyway, yes, we have user name, and for username, what I want to do, let's just something like that, small box, and in this box we can put some verbs. I don't know what we can put there, just it can be my name. I don't know, maybe you can put your name too there. Okay, and also can be I will duplicate it. Here, because will be 3 place like that, and it will be like that. And second one will be birth date, Third one will be primary language. Primary language. Language. Our primary language can be English. I'm just learning all things. I'm not professional on all things, just but I'm improving my skills. I love to improve my skills, and it will be 10. Yeah, it will be like that. Okay, but it will be something like that. English, and yes, we have here one thing you can see now. I will show it to you. We have one one box like that. Yep, and this box just like black, and in this box just we have this green, and we just want to, where is it, green? I want green. Yep, this green, it's just something like that. Okay, now this is something like, anyway, now I will show it to you. It will be like sound, something like that. Yes. Now this is also that. Now what have you see here? What do you think? What's our goals here? Goals here for solve this situation. Okay, now we can gonna write here again. We can say, I think it's up. Maybe I will look up again for, yes. For here we can write which of the settings can be stored, I think you got it, can be stored in a single bit. Like, just think, in single bit we have two possibility. What do you think about primary language? There is any possibility, and also I think there is too much words, so I think there is really, so lots of bits, I think, because there is some words can represent some numbers can be one, so I think it is not. So what we can do, so anyway, so first I will write, anyway, I will come here, a single bit, we set that, and I want to do something like that. And yes, we have a the, maybe we can write first here, say user, now user name. We can write also birth date. We have also primary language. Also, last one we have sound effects. Yes. Where we see, now we can look together, right? I will take my pencil again. Yes, if the things is true, I will do something like that. If false, I will do with red like that. Anyway, now my name is Mohammed. Okay. What do you think here? I think here we don't have 2 bits. This is too much bits because D can represent 0 or 1, so 1 and some numbers. Okay, there is lots of data. Okay, lots of bits. So each word can represent 2 possibility, D or no, but I think it's here 1. Anyway, I think this is this is not true. Birth date. Oh, we have 7. 7 can represent some bits. 10 can represent some bits. And lots of things have here. I think there is not 2 possibility. It's not 2 bits. 1 bits can represent true or false. Things or not. This is no. This is so something like that. Primary language, of course not. And what we have, can say green. Sound effects. If you check, we have here 2 possibility. This is open or not open. So 2 possibility. This is, so we can think like that. This is this or no. Yes, 2 possibility. So I think this one true. So if we come, the question is which of the settings can be stored in a single bit? We know single bit can store only 2 possibility, so this one true. The other ones is not true. Okay, the other ones just can store lots of possibility. Each words can represent 1 bits, and there is 1, 2, 3, 4, and more and more. Okay. It's also finished. So we can say now here, yep, sequence. Sequence. Wow. Sequence bits. Yep. It can be like that. Maybe color can be different. Something like that. Okay. And come here. Okay. Computers use multiple bits. Computers use multiple bits to, yep, bits to represent data that is more complex. That is more complex. Complex than a simple on off value. Yes. A sequence of 2 bits can represent 4, so like 0, and also what we have here, what do you think? I think you know power of numbers, right? This is power of 2. What will be this? 2 times 2, like, what is this? This is 4. Okay, anyway, can be something like that. And distinct values, right? Distinct values. So what I'm saying is a sequence of 2 bits can represent 4, so 2 distinct values, right? Will be, anyway, now you will see what I'm saying. I don't want to mix your brain. It's 0 0 1 0 1 1 0 1 1. Sequence of this of of 3 bits, 3 bits. Now just you can think 3 bits can represent can represent 8. So it is, what will be, what do you think? 2. So just think. I think it is something like that. Power of 3, but what power of 3? What can be? Something like that maybe? What do you think? I think this is true, eh? Anyway, you will see. Or we will see together. 8, so it's 3 different values. So like what? Like that. 0, 0 0 0, and 0 0 1, and 0 1 0, and 0 1 1, and 1 0 0, and 1 0 1, and 1 1 0, and 1 1. Okay? Do you understand what is this 3? Look at this 3. 3, it's that. Bits. Okay? What do you think about 2? What is 2 here? What can be 2? Power of 2. So 2. So 3 times 2, like 2 times 2 times 2. So it's 2 times 2, 4. 4 times 2, it will be 8. And we have 8, right? 8 times 3, it will be 24. There is 24 bits. Yep. So now we will say a sequence can represent many things. Yes, a number, a character, a pixel. Yep. Plus plus the some what I'm done. Some sequence can represent different type types of data types of data in different context. different context, and the sequence, the sequence 1 0 0 0 1 1 could could represent could represent 67. This is very important in in a character, you know, right? 2 times 1, 1 times 1, 2 times 1, and it's all the way going here. We have 8 bits. It will give us, yeah, I think you know what I'm saying. It will give us 67, okay? Anyway, character, no, in calculator, yes, calculator, application, while also representing later C in text file learn. So I think you got it, okay? Computer can represent 67 with these numbers. I told you 1 times 1, 2 times 1, 4 times 0, 8 times 0, 16 times 0, and 32 times 0, 4, so it's 64 times 1. Now if you count them, then you will get this number. Or if you can, you can do also for it, for C. Okay, this is one. Now we will look for bytes. Okay. Now we can come here. We can say here bytes. Bytes can be red. Okay. And faster I will come here and I will start. Bit is the smallest piece of information. So listen here very carefully. Information in a computer, single single value storing either 0 or 1. Okay, a byte we are coming now to speak about byte is a unit as a unit of digital information. So we are using bytes now. This is good. Information that consists. So why we are using? Because we want to store lots of information than 8 bits. So then 1 bits, then 2 possibility. We want to put there lots of information, like just think there is a 64-bit computer can store their 128 possibility. Okay, hundreds, so there's lots of information can be in one place. Okay, in numbers consist of 8 of bits, 8 of this bits, I think. Okay, 8 of this bits. So what I said here, A byte is a unit of digital information that consists of 8 of these bits. So 8 bits, just 1 byte, okay? 8 bits, only 1 byte. And we can, computers can speak with bytes, okay? With bytes, not with bits, because bits is smallest, little more smallest, and we want to store too much information, and it's really too much difficult. We will speak too much about it, and I will say here, here's a single byte, single, uh, single byte. Here is a single byte of information. Okay, it is like 11110. Yeah, 10110. Friends, this is just 1 byte, okay? 8 bits, only 1 byte, okay? Now let's speak again. 1 minute. Wait. We will look all details. Here are three more bytes of information. So now we will see 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 1. Now we have, look at here, this is 1, this is, so this one is 2, and this one is 3. So we have totally 1, 2, 4 here, 8, 12, and 2, 4, 8, 12. So we have total 24, okay? Now you will think, what is this 24? Now we will understand. 24 just divide 24, divide 24, 3. Now we will see there only 8, okay? Then you can find solution about it. Okay, now, so 3 byte, just 3 byte, 24 bits. If you want to say 32 bits, it will make 4 bytes. If you say 64 bits, it will give you 8 bytes. Okay, just you can count like that. Now we can say from now we can say from bits to bytes. We can change this color. Maybe, I don't know, some color like that. Just for indicate this is important. So we want to write something, some information things there. Anyway, how I will start conversion. Conversion between bits and bytes is a simple calculation. Divide by 8 to convert from bits to bytes, or multiply. Now what I'm saying here, if you want to find bytes, you have to divide all collection of all the bits to 8. Okay, then you can find bytes there. If you want to find bits, then you have to multiply bytes time 8. Okay, just because 8 bits 1 bytes, 1 bytes 8 bits, just you have to multiply 1 time 8. It's 8, 8 times 1, 8 divided 1, again 8. Okay, this is some equation. Okay, multiply, we said multiply by 8 to convert from bytes to bits, and how many, and now this question, bytes how many bytes long is this binary sequence? So this is the question for you. So I will come down, and okay, I will put there maybe something like that, and again, and 00110101, and maybe 11011111. I think something like that. It's not wrong. It's 368 like that. Then 248 here, and also it's here, and this one here, and this one here. Okay, it is something like that if I'm not wrong. Okay, this one is 8. Also, really my eyes not seem good. So what do you think about that? Now I will stop. You can count them. Then you know what you have to do, right? I wrote all the information there for solve it. What do you think? Anyway, now I can go on. Now we can count it. And it will be here 8, and this place will be again 8, this 16. Now this place will be 8, this will be 24. It will be 8 again, it will give us 32. 2, and this place will be, it will be 40. Now we have 40 bits. What we have to do for find 2 bytes? We have to divide 42. We have to divide 40 what? 8. Like, yes, because our bits this. Yep. Now what we have to do, we will say it's 40 divide 8. It will give us 5 bytes, right? It says 5 bytes. 40 bits equals 5 bytes. 5 bytes, 5 times 8, 5 bytes. So then we can find 40 bits, right? Anyway, so also you can solve here one question. How many bits are in 8 bytes of information? This is really not big math. You need not too much math. It's just something. Okay. You have to know some small information. So yeah, just solve it. I'm waiting you here. This is really not difficult. If you want, you can do it. Really, you know what you have to do. 8 bytes. We have 8 bytes information. I'm waiting. First you. Okay. Now I will come again. Now we have to do 8 times what? 8. We have 8 bits and we have to multiply our bytes to bits. Then we can find bits, right? What will be? 42? No, 64 bits, right? 64 bits. It is our solution for this. Okay, this is also good. Now we will say y bytes. Here, this is some kind of logic, y bytes. And now we will look here. Yes, and now we will write something from here to I don't know where. Now we will start. Okay. So okay, just start to write things here. Right here. Yep. We can start now. Too much things. What is so special about 8 bits that it deserves deserves its own name. Yep. Now computer do process, right? All data has bits, but but they prefer to process process bits in bite-sized. So bite-sized, right? Groupings, groupings. This is very different word. Or to put it another way, byte byte is how much computer 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 likes to byte byte at once. So just computer want to work with bytes, okay? Bits too much small stuff. So for that, computer working with bytes. But you have to understand this concept. The bits always computer working with bits too much in depth, but it's just something we doing together, okay, with bytes. Anyway, I will come down now again. So now we have last one here. We have last one here. Now I will show it you. Also, I will want to show you something here. Maybe you can think something like that, and just think we have some words here. So something like that. This is some words, okay? there is something like that. It's just there is numbers, okay? You can think like this message box, okay? Gmail box, message box. Is there is like 1000111 and 01011011 and 11101011. Something like that, okay? You can think like that. This is the logic of this way. And also, last, we will write something more here. The byte is also smallest addressable sable unit of memory in most modern computers. Right, a computer byte unit byte addressable memory cannot store cannot store on individual individual piece of data that uh, data that is smaller than byte. So the byte is also smallest addressable unit of memory in most modern computers. A computer, I can edit here. A computer unit byte addressable memory cannot store an individual piece of data smaller than a byte. Yep, so I think you got it. So now I will show it you again here one example. We can see it like that. This is some information place. This is the place here. We have address. We have data. This place can be different color. Maybe green again. Yeah, maybe green. Maybe green, right? Maybe green, yes. Maybe green, yes. Now I will look here. Yeah, maybe. I want to do something, but it's reading. Okay, maybe we can change this ones here. Okay, it can be like that. I will not touch here. We can do something like that. And this place can be here. This. And maybe I can take it here. Maybe no, I will delete this one and just I will add here just one thing, or I would say memory. Yep. So this color can be red, maybe, right? So then we can put here some numbers. And where it one, it can be It can be white. So anyway, it's some white. And yes, 1111000. Also, it's 2, and for here it will be 00001010, right? It will be for 3, like that. From here, and 0011100110. And also for will be like this, 11000001, something like that. And we can put it here. Anyway, information piece of place can become like it's 10. Okay, something like that. And up, we can take it also here. Just come this place. Yep. Yes, this one here. We will say how we find these numbers. Yep, maybe you're thinking like that, or this can be like that. Anyway, we will speak about that. So how we find these numbers here, we will speak about that, okay? Anyway, now I will come down. And the last one, I will say what is what in a byte, what in byte. And we can do it 13, and we can do color something like this, but before do things I can do it like that. Okay, I told you also this will be like 13. Yes. What is in byte? Yes. Some kind of logic here. Now a byte represent, again, byte represents different different types of information depending on the context down. Yes, here on the context, it may represent a number, letter, or a program, or program instruction. It instruction. It's not interaction. It's instruction. It may even represent part of an audio recording or pixel in an image. In an image, we'll explore how computers can use bits and bytes to represent all types of information in this unit. So it is all. Now we finished this subject. I mean, our first topic in digital information, how to computer represent data. We already done it, and also maybe we can do click here, something like that. It's finished, and we were speak about binary and data, and we gave lots of we gave lots of details, examples, and too much more. So you know how to count now binary numbers, how binary numbers going on, like how we are counting bits and bytes, and we saw their images, videos, graphics, and audio waves, so how we can understand bits of sounds, range of sounds, and quality. And we saw lots of things there, and also we saw bits, 8 bits and 1 byte, 1 byte, 2 bytes, 16 bits, and 5 bytes, 40 bits, 40, so for 60, 64 bits, just 8 bytes. Now you know now how to count these things, right? And we know 1 bit, there is can be 2 pattern, like things true or false. There is 2 possibility in 1 bit, right? In 2 bits we have 2, we have 4, 4 possibility, and in 6. So it will be really different, okay? All the time it will change. You know now how to say how to represent 67 with the binary system bits, like you know, 1 time something, 2 times something, 4 times something, 8 times something. It's binary logic, okay? It's not like our decimal system. It's all about that. It's also finish. Maybe here it will be good. And bits and binary digits finish, and bytes finish. You can go for more example. Maybe there is some website we can look. Binary bytes exercise. No, it's exercises. Bits and bytes exercise, grammar bytes exercise, or some other ones. Okay, you can find too much here information. Maybe here you can go some website, bits and bytes exercise. Anyway, this is our doggy. Okay, this is all finished now here. Our first topic. So in digital information, it's, I told you, no, yes, in bits and bytes. This all in bits and bytes, okay? It's our first topic, bits and bytes. Maybe I can write also here. Maybe like bits, bits and bytes. So our first topic is that. Let's finish. Have a good time. See you later. I hope you enjoy it. Maybe you were tired too much. I'm too much tired too, like you. See you later. Be careful reading.